Our first speakers come to us from Norwegian Air Ambulance, and their mission is all about people, specifically the safety of people. And probably the best way to see what they're all about is through a short video. Can we roll the video, please?
Men vi kommer til å varsle helikopter og ambulanse som kommer til dere. Oppdrag til 18.4.
Bare kom oss av gårde, så tar vi med Lukassen.
Så været ser fint ut. Der
Yes, det er good.
Altså. Klart venstre. Gjengen. 2-3 klare.
Well, that was the warmest of welcomes. I was going to say, please join me in welcoming Norwegian Air Ambulance, Edward Muir and Jorgen Sturley.
So we are very pleased to have been given the opportunity to share our experience using ArcGIS in the Norwegian Air Ambulance. Today, we will show how geographic information, real-time data, and mapping technologies support critical medical operations, and how ArcGIS help us to make faster and safer decisions, often in very challenging conditions. First, Edward will give a short introduction of who we are and what we do.
Thank you, Jørgen. Norwegian Air Ambulance consists of 3 main parts. The Norwegian Air Ambulance Foundation is an independent foundation funded by private persons and corporate partners. The foundation's primary focus is research, innovation, and education to improve the air ambulance service and pre-hospital emergency medicine. This is a bonus to the Norwegian healthcare system. The foundation also has a research and development helicopter. The air ambulance service is part of a national healthcare system, and the government funds the service and is responsible for it. The service is divided in ambulance fixed wing and helicopter emergency service. The helicopter emergency medical service is operated by Norwegian Air Ambulance Helicopter. Norway has 13 HAM spaces and 18 helicopters, and Denmark has 5 HAM spaces and 5 helicopters. Norwegian Air Ambulance technology is also part of the Norwegian Air Ambulance system. Jørgen and I are working there. We are developing the infrastructure and technology that enable world-class air ambulance services nationally and internationally. Weather is the most unpredictable factor affecting the air ambulance operations. To address this, the Norwegian Air Ambulance Foundation has deployed 240 weather camera stations across Norway, Sweden, and Denmark. To display this data, HEMS Weather was developed. A web application for stationary use and a mobile application for use in helicopters, aircraft, and by all the mobile users. Additional support functions like weather, obstacle information, and task details have been added over time. Hemsweather has more than 10,000 internal and external users in military and civil aviation, ground operation, and at sea. Jens, the pilot in the picture, identified a need for better weather understanding in remote areas. Installation of weather stations with digital cameras started 10 years ago. These stations capture images every 50 minutes and include sensors for temperature, cloud height, and air pressure. In the Air Ambulance Operations Room, Hemsweather is a critical tool for deciding whether to accept or reject a mission. Fast and informed decisions are vital to ensure the best outcome for the patient. If a mission is rejected, alternative resources must be promptly deployed to avoid delays and minimize the risk to the patient. Hemsweather provides the necessary information for assessing weather and operation conditions, allowing crews to make optimal decisions efficiently. The Hemsweather app is available both as an iOS and an Android version. And I think of this app as a Swiss Army knife. The crew members also use the app on mobile phones. This is the picture of the Hemsweather web solution showing some of the information available. And Jørgen, could you tell us more about the technology we have chosen?
So Hemsweather was released in 2016 as a weather map solution, integrating live weather cameras and VMS weather layers. It was available on both mobile and web platforms. The mobile platform was built using Xamarin Native and used Apple Maps on iOS and Google Maps on Android. The web application was developed in JavaScript with Google Maps. Because there was 3 separate map implementations, the map-related code was developed 3 times. Most of the application logic ran on the client side. So in 2021, we got new mapping requirements driven by operational use. We needed maps from the Norwegian Mapping Authority, combining with seamless cross-border coverage for Sweden, Denmark, and Finland, since our mission don't stop at the national borders. Elevation had to be shown in feet aligning with aviation standard, and we needed layer-based maps, including VMS services, to integrate operational data. Just as important was offline support, ensuring reliability in low connectivity environments. Finally, the solution had to work within our Xamarin-based mobile application. So, by accident, Google, I found that the Norwegian company Geodata provided the required Nordic map. Their maps were built on ArcGIS, which at that time offered native SDK support for Xamarin, allowing us to integrate the maps directly into our existing mobile code base. To integrate ArcGIS properly, a full rewrite was unavoidable. I was a Xamarin developer, so naturally I was skeptical about switching frameworks. However, the team believed Flutter would increase development speed, and in practice it did. Esri did not at that time have any Flutter SDK. We solved this by wrapping the native ArcGIS Objective-C and Java SDKs, which we published as a public GitHub library. This gave us a clean, maintainable bridge between Flutter and the native runtime. So I posted on a forum that we had built a Flutter wrapper around the ArcGIS native SDK and said, use it if you want. It was originally meant for internal use. Jake Shapley read the post and used it in the Fishing Washington app. This was demonstrated at the Esri Developer Summit here in Palm Springs. That demo caught the attention of the Esri team, which triggered their interest in Flutter. This is a great example of the impact of sharing a solution openly. The version 200 of the SDK was written in Swift and Kotlin, so we had to rewrite the wrapper. It was time-consuming. We used more than 1 month working on this, but it was important to have our application updated with the latest SDK version, so the effort was needed. When the new ArcGIS Maps SDK for Flutter was released in November 2024, our delivery speed increased immediately. We now did not need to write own code to use SDK features. We could just use them, so it was much faster to add new features. S-Series SDK is built closer to the core runtime than our wrapper. That was essentially a wrapper on top on a wrapper, making it faster and more stable. The first version of the solution that meets the core requirements defined back in 2021 will be released later 2026. This release introduced key capabilities such as offline map layers and map clustering, which is essential for real-world operational use. Looking ahead, we expect significant optimization in the next SDK version. These improvements would further enhance performance, stability, and overall user experience, making the application even more robust over time. While there are still some challenges, our overall experience with the ArcGIS SDK has been very positive. Not every ArcGIS web capability is immediately available in a native SDKs, and the Flutter SDK currently trails slightly behind its Swift and Kotlin counterparts. From time to time, fixes also take longer than it would ideally like to reach the SDKs. That said, the advantages clearly outweigh these limitations. The core mapping experience is solid and dependable. Rendering and performance is strong on both iOS and Android, with smooth interactions, fast loading layers, and stable behavior across standard use cases. One of the biggest wins from a developer perspective is the move towards a single cross-platform SDK. This dramatically reduced the overhead of maintaining parallel native implementation and allows teams to focus more on delivering value rather than managing platform differences. Development becomes faster, more predictable, and easier to scale across platforms. Another important shift is architectural. More functionality now lives inside ArcGIS itself, rather than in the mobile application. This reduces complexity in the mobile code base, improves maintainability, and ensures far more consistent cross-platform behavior. For developer, this means less custom logic, fewer edge cases, and cleaner, more focused app code. Edvard will go into more detail on this next.
Our change to ArcGIS has been a game changer for us. It gives us a lot of new possibilities and reduces the workload to style and publish maps and layers. Hemsweather uses many different sources of data. To the primary services, our own backend solution serving different datasets and user administration, and ArcGIS Online serving background maps and several layers of information. The web version and app version uses the same items from ArcGIS Online. As Jørgen explained earlier, we have moved from Google Maps to use SD products. ArcGIS Online is now our main hub for serving geographical information. Geodata, the SD distributor in Norway, delivers different products. We connect to different VMS, VMTS services and examples of different weather layers. Coop is used to format and distribute Save Sky information and is updated every 2 seconds. ArcGIS Online Notebook is used for nightly update on Norwegian obstacle data. Several products are updated manually, but we work towards setting up automatic updates when it's possible. We also recently started to use data pipelines that make it possible to add our own API data and removing the need to handle and style the information in the web and app code. Weather is the most unpredictable factor in our ambulance operations. That's why we focus heavily on delivering high-quality weather products to our pilots. We work closely with the Met services in Norway, Sweden, and Denmark to ensure accurate weather information. Here are some example layers. Our helicopters can now fly in icing, and the route forecast shows the cross-section for predefined routes in Scandinavia and gives important information about icing conditions. Radar precipitation is important to avoid dangerous weather conditions, and helicopter trigger lightning is also important to avoid. In 2014, we had a fatal accident when one of our helicopters hit unmarked power lines. 2 crew members died in this accident. Accurate obstacle information is critical for safe operation, especially during landing and takeoff. Norwegian Civil Aviation Authority regulates the reporting, registration, and marking of aviation obstacles. Then the obstacle owner reports to the Norwegian Mapping Authority by web client or by a machine-to-machine interface. Norwegian Mapping Authority is responsible for the obstacle database, and the users access the data via download or an API. We have automated the transfer of obstacle data to our ArcGIS online solution. Then the data is used in the Hemsweather and app and web. Hemsweather has obstacle information from Norway, Denmark, and Sweden, but the styling requirements are different, are not standardized. Arcade and ArcGIS Online is used for styling, calculating pop-up information, and label information. We also use the notebook for automatic updates on Norwegian obstacle data every 24 hours. There are 1.6 million registered obstacles in Norway, and the number is increasing. Our Hemsweather solution also delivers dynamic aeronautical information to many different users. Examples are ambulance, police, and search and rescue helicopters. Here are some examples of aeronautical information. SafeSky uses more than 30 sources of information. Drone operations are planned drone flights. And the view on helicopters uses flight cell tracking system. And Jørgen, could you tell us a little bit more about the road ahead?
Today, we mainly just displays data. We have a lot of data available, and it's easy to just add more. We are working on how to use the data and consider the possibility of delivering a smart route planner or perhaps an assistant. The goal is to identify the possible routes considering terrain, obstacles, weather, and other factors. AI may help us achieve this. The routes will have relevant information, and the pilot can use this as a help on their final decision. Our next step is to bring all this data into 3D. What you see here is a replay of an actual mission in Norway. Behind visualization, we want to explore predicted flight plans combining terrain, obstacles, weather, and other relevant GIS data. Right now, this is strictly a proof of concept. The key part is defining the use cases together with the user, whenever that is planning, debriefing, or training. We believe this could become a valuable extension of the solution, but it has to be driven by real operational needs. So you can also scan this code to get a story map that Esri made about how we built this Hemsweather solution on Flutter. So it's easy to be caught up by the technology. The patient doesn't care about how the doctor got there. The goal is to develop solutions that enable reaching the patient as quickly as safely as possible. Thank you.
Jørgen, Edward, thank you for that. I wanted to present you with this award to memorialize all the work that you and your teams have been doing. So please, our organization, Esri, is very grateful for your partnership and your hard work. So we thank you for that.
Thank you.
Thank you very much.